Let's learn how to graph radical functions. We're going to graph the parent functions for square roots and cube roots, and we'll graph transformations, and we'll identify some properties. You'll need your notebook, pencil, and calculator. And let's start with the parent graph. So the parent graph, the parent equation, is before any other numbers have been added. And here we're looking at y equals the square root of x. So when you don't know what a graph looks like, a good place to start is a table of values. So let's start by plugging in -1. So if I have y equals the square root of -1, well, we know that that is I, but that's an imaginary, and we're just graphing the real numbers. So that is nothing. What is the square root of 0? The square root of 0 is 0. What is the square root of 1? 1. Square root of 2, I don't know off the top of my head. Square root of 3, I don't know off the top of my head. So better value for this table would be the square root of 4. So I'm going to get rid of those and do the square root of 4. The square root of 4 is 2. So when you're making a table of values for a square root, you can't just randomly pick your x's. You really should put some intention into what you pick for your x so that you have a perfect square you can take. The next perfect square would be 9. So the square root of 9 is 3. And now I have some values I can plot. So I'm at 0, 0, 1, 1, 4, 2, and 6, 7, 8, 9, 3. And we have those 4 points. Kind of looks like a line. They are getting bigger, but it is going to be a curve. So it starts at the origin and it curves, and it's going to have one arrowhead. Really important that you draw the arrowhead to show that it goes on forever. So not like a quadratic. It doesn't have a vertex. It has this starting point, sometimes also called the end point. I think it's actually called the end point. That's the point that we're going to want to use with our transformations. Let's look at how that changes when we have the cube root of x. So y equals the cube root of -1. Well, we didn't really talk about cube roots of -1, but if I want to think of a number that multiplies to itself 3 times and equals -1, that's what this idea is, and those are all going to be -1. So the cube root of -1 is -1. What is the cube root of 0? What times itself 3 times is going to be 0 is still 0. What is the cube root of 1? That's going to be 1. And again here, 2 and 3 are not going to be very helpful. So if we just did 1 cubed is 1, the next number we might try is 2 cubed. 2 cubed is 8, which then if we do the reverse, the cube root of 8 is 2. So the value I prefer for my x is 8. The cube root of 8 is 2. 3 cubed is 27. So that would be a good value to plug in for x. It kind of seems big to plug in a 27, but the cube root of 27 is just 3, so it's not so bad. So I have -1, -1, 0, 1, 1. And if I just look at that, that looks like a straight line, but be careful, it's not. It's a cube root graph. So when I go to when I go to 8, I'm up 2, and then obviously 27 is way off of my graph. This is how I would like you to draw it. I want you to start at the origin and draw what will look like a square root with that tail, and then go back to the origin and do it the other way, like that. And that's going to be a continuous, it's kind of a stretched out graph. If this was +8 and I was doing -8, so the cube root of -8 is -2. So I would have some value way over there. You can take the cube root of a negative because you're multiplying a negative 3 times, which gives you a negative. So that is allowed, and that's why it's continuous and it goes both ways. Take a look at these two equations, and what do you notice? Hopefully you see they all have an x and a y, an a, and an h and a k. So the first one is our vertex form for a quadratic. We've already concentrated on how this transforms with the shifts. And the good news is it's going to transform the same way with the square root. So with our quadratic, when it was in with the x, the h moved it left or right, and it went opposite. So if it was x minus 3, that means it's going to go to the right 3. The same thing's going to happen with our square root. It's just a different grouping now. It's not a parentheses squared. It's a group square rooted. So h is still going to move it left or right and opposite. The k that comes after, that's going to shift it up or down. That's going to change my y. And the same thing here. It's going to go up or down. Exactly what it is. So if it's plus 5, it's going to go up 5. And then the a, we have this a in quadratic and square root, and it's going to be very similar. So a has a lot of power. They shift the same way, and here are our shifts. So we saw with the quadratic, if a was negative, that meant it's going to open down. We also have just seen our parent graph for our quadratic. That might be y equals the positive square root of x. But now if I think about the reflection of that, that's going to be negative square root of x. And all of those y values that we just came up with are now going to be reflected. So it's going to look like that. So if a is negative, we'll say it's reflected over x. If a is bigger, it's going to be vertically stretched, which kind of just means it's going to be taller. If a is between 0 and 1, it's going to be vertically compressed. So I'm going to be squishing it down, so it's going to be squished like that. H is going to shift left or right, so it's changing the x, and it's going to go opposite. K is going to shift it up and down, so that's going to change the y. I just wanted to share with you kind of what it looks like in Desmos. So you can see in my equation, I changed all of my a values, 2, 3, 4, and I threw in a negative. So this is 2 square roots of x, 3 square roots of x, 4 square roots of x. And it's being horizontally stretched, so it's being pulled up, vertically stretched, so it's being pulled up in that vertical direction. And then the red graph and the purple graph are the reflection of each other. So we have that negative, which is making it reflected over x. If a is between 0 and 1, so probably a fraction, you could have a decimal as well, I put the black parent graph on here. So here's my starting graph, and then I'm compressing it. So vertical compression, I'm pushing it down. So let's try to graph with some transformations. So how does this shift? Well, the number is inside with the x, so that means it's going to go to the right 3. It was at 0, 0, so I'm going to go to the right 3, and I have that point in my table. If I pick something less than 3, now that I know where the shift is, it's just going to end up being negative. A 2 minus 3 is negative 1. 1 minus 3 is negative 2. And we're not graphing any imaginary numbers. So from here, I just want to go up, but again, I want to give intention to what my x is. So would 4 be a helpful x? Let's see. Then we're going to have the square root of 4 minus 3, which is the square root of 1, which is 1. So that's good. And I have the point 4, 1. Would 5 be helpful? 5 minus 3 is the square root of 2, which I can get the decimal, but I don't really want to use 5. The next perfect square is 4. So if I think about x minus 3 equals 4, then x would have to be 7. So that's going to be a good x value. I put 7 in, and I do the square root of 7 minus 3, which is the square root of 4, which is 2. So I have a point at 7, 2, and then I draw that with my arrowhead. You can see it was my parent graph shifted to the right 3. Let's take a look at this. This is the square root of x, and then the plus 4. So that's going to move the whole thing up 4. So I'm going to start with 0. And if I do the square root of 0, that's just 0 plus 4. So we're at 4, and we have our y-intercept. I know that I'm going to go to the right, so I'm going to pick things bigger than that. And it is just the square root of x, so I want to stick with perfect squares. So I'm going to do 1, 4, and 9. Square root of 1 is 1 plus 4. So that's 5. Square root of 4 is 2 plus 4, which is 6. Square root of 9 is 3 plus 4, which is 7. So 0, 4, 1, 5, 4, 6, and that will be enough. but that's my parent graph shifted up 4. Let's put a couple transformations together. So this is going to go to the right 1 and down 3 from our starting spot of 0, 0. So I'm going to go to the right 1 and down 3. And this is my actual point, so we're going to ignore those. So I'm at the point 1, negative 3. 2 would be a good value. The square root of 2 minus 1 is the square root of 1, is 1 minus 3 is negative 2. 3 is not helpful, 4 is not helpful, 5 would be helpful. So if I have the square root of 5 minus 1, that's the square root of 4. That's 2 minus 3 for a negative 1. So I'm going to plot 2, negative 2, and 5, negative 1. And it looks like my parent graph, but shifted to the right 1, down 3. Let's graph here y equals the cube root of x minus 2 plus 1. Notice this has a cube, so this has to be this sideways stretched out S shape. It's still that middle 0, 0 point that we are shifting. So how does it shift? Well, it's going to go to the right 2 and up 1. So from 0, 0, I'm going to go to the right 2, up 1, and that's my point, 2, 1. And with the cube roots, you should pick numbers less than 2 and bigger than 2 so you get both shapes. So I'm going to put 2, 1 down here and erase that for a minute just so it's in the middle. I'm going to pick numbers less, 1 and 0 will be good, and then we'll see what happens. So if I plug in 0, not so helpful because I don't know this cube root of negative 2. If I plug in 1, the cube root of 1 minus 2 is the cube root of negative 1 is negative 1. Negative 1 plus 1 is 0. I'm going to go bigger, so I'm going to go to 3, and it's going to be a similar idea. The cube root of 3 minus 2 is the cube root of 1 is 1 plus 1 is 2. So 3, 2. And our perfect cubes, so we have perfect cube of 1 and then the perfect cube of 8. So if I want x minus 2 to equal 8, that means x is going to be 10. So another good value to plug in would be 10. And then when I do the cube root of 10 minus 2, that's the cube root of 8. Cube root of 8 is 2 plus 1 is 3. It's not going to fit on my graph, but remember that that's my middle point. So I'm going to draw that one branch, and then I'm going to draw the branch the other way. So just remember with cube roots, you can take the cube root of a negative, and you have to continue with this other side. So to recap, determine if it's a square root or a cube root graph that you're dealing with. Use your transformations to shift, to move that middle point from the origin, and then use a table of values to find 2 more points. Nice job.